All right. So now that we have in part A, this was the lengthy one where we had to analyze the data that we were given and figure out the empirical formula. We're now transitioning to question B, which is determine the molar mass of the compound if the density is 6.09 grams per liter at 298 Kelvin and 0.98 atm. So molar mass, we have to understand what it is. So there's a couple of ways that we can calculate molar mass. If we know what the compound is, we can simply just add the masses up on the periodic table. Well, if they wanted the molar mass of just the empirical formula, that'd be pretty easy, right? But they want to know the molar mass of what the actual compound is. Empirical formulas only show the simplest ratio, multimole ratio of that compound, okay? These big complex organic compounds, they could be double, triple, quadruple times that. So we want to figure out what the formula actually is, okay? So if they want us to find molar mass and we don't technically know what the molecular formula of that compound is, there's two ways to figure it out. If they had a gram amount and a mole amount of the sample, we could just divide grams per mole, grams divided by moles, and that would give us a molar mass. But they didn't give us this information. Instead, they gave us a density. Now, whenever you're trying to find molar mass and you're given density, there should be an equation that automatically pops up in your head. And that is molar mass equals dirt over P, where D stands for density, R is your gas constant, 0.0821, T is your temperature, and P is your pressure. This is an equation that is not on your equation sheet because it's derived from PV equals nRT. Hopefully you guys remember PV equals nRT from previous chemistry class or maybe even 8th grade. This equation here is actually derived from that, so it's not on your equation sheet, okay? So all I have to do to find my molar mass is plug those values in, make sure my units cross out properly, and then that will give me my molar mass. So let's go through that. D stands for density, so we're going to plug in our density, which is 6.09 grams per liter. R is our gas constant. So that gas constant we're going to use, this is on your equation sheet, is 0.0821 liters times atmospheres divided by moles Kelvin. Let me do this way so we can see how those units cross out. T stands for temperature, and that temperature given to us is 298 Kelvin. And P stands for pressure. That pressure is 0.98 atms. So when we solve for this, we want to make sure that the units cross out properly. If we want molar mass, then the units that we should be given at the very end is grams over mole, grams per mole. So I have liters, that's on the bottom here, and on the top of this little division sign, so that cancels out. I have Kelvin that's on the bottom of this division and on the top here, so that cancels out. And I have ATM on the top and ATM on the bottom, so that cancels out. So do you see how the unit we're left with is grams per mole? So therefore we know that that is our molar mass. When I work through this calculation, you should be able to get your molar mass, which is 152.04. Did y'all get that? Let's see. Let me double check. Yes, 152.04 grams per mole is our unit for molar mass. So this is the answer for B. So what this is telling us is that whatever the molecular formula actually is, it is that particular mass. So that leads us into our next question, which is determine the molecular formula of the compound. Well, molecular formula can be found by finding the multiple that we have to distribute through here. So for part C, to find the molecular formula, I need to know what number to distribute through that empirical formula. And to do that, we look at the ratio of what our molar mass actually is versus the molar mass that we get from our empirical formula. All right, so here's how we calculate that number we distribute through. It is the actual molar mass divided by the molar mass of the empirical formula. So let's look at those two things. The actual molar mass is what we calculated in part B. So we're going to plug that in, 152.04 grams per mole. The molar mass of the empirical formula, where we get that number, is by adding up the molar masses of our empirical formula. So we have to add 3 carbons, 8 hydrogens, and 2 oxygens. And when we do that, we get a molar mass of 76 grams per mole. So again, this number here came from us adding up the masses of our empirical formula. When we divide those two numbers, we should get 2, right? We get our number that we multiply through our empirical formula, which is 2. So what this is telling us is that our molecular formula is double the mole ratios that we see in our empirical formula. So our empirical formula was C3H8O2. So our molecular formula is double this number, so C6, double that number, H16, double this number, O4. And this is the final answer for part C. So guys, this is an AP level type question. It will be on free response for molecular, for mass percents, which we didn't have a mass percent question in here, but you'll see it later in the assessment. This is how it's going to take us into empirical and molecular formulas. So hopefully you guys have some insight on how to navigate these questions.